talk about, how and when you might reuse 3D, right? So if you're using 2D, great. You just, started building up a library of components that you can reuse for your designs. But what about reusing existing 3D? You don't have any, right? So we'll talk about that in just a moment. Where do you get it? But let's talk about when. Again, similar criteria, preferably static parts or components that don't change or move. And in a lot of cases, they're purchase components. Okay. And again, you may be building a library of your own of these things that you typically purchase and don't change. You just consume them. And there's a lot of websites out there where you can download these directly. So again, not a good fit for things that maybe change. If they can be swapped out, that's one thing. But if you're taking and downloading a part or an assembly and you want to stretch it, that's typically not yours, right? Or maybe it doesn't have information that that lends itself towards it, and of course automation as well. So be careful with that. If you're gonna automate some of this, take a careful look as to, is it going to stay static within the automation, or are you planning to stretch it, change it in a number of ways? Okay, so let's now take a look at sources for this data, right? So a lot of these tools come with existing libraries of information. Plant 3D does, right? Revit does, and Inventor's no different. Inventor has three-quarters of a million plus standard parts that you don't have to build. So the nuts and bolts, they're there. The pipes, they're there. And even if you just need a variation on that pipe, it's customizable so that you can create a different version of the pipe that's there. They might only have stainless steel pipe and black pipe, and you might want to create galvanized pipe, right? You can customize the existing pipe that's there so that it reflects the right material, the right part numbers. And again, we have tons of videos on that subject. You don't have to create it. It's already ready to go with parameters and stuff to help you edit those, right? And it fits into the automation scheme. It can use some content center information. We know how that works. If you're going to get data from vendors or suppliers, you're going to have to import that data from somewhere. If you're fortunate enough that they have, the same tool, they could just bring it in, right? But in a lot of cases, you're going to have to work with neutral formats, right? Exchange formats like STEP or IGES, or, you can see some of the lists there. STEP is preferable. It's probably one of the more common ones. And, for some reason, your customer has a different tool. They can send you their native format, their native SolidWorks files, Creo, et cetera. In a lot of cases, Inventor can work with that directly. And the one caveat that you're going to want to think of is they gave you those files. It's their part, their design, and they're focused on the details, right? The details of a breaker, the details of a motor that they manufacture and sell to you. And they have a lot of internal components, a lot of little nuances. That is 100% their focus. For you, this might be just a tiny thing that makes your overall design, and it may contain too much detail. In fact, last week we spoke to a customer and they sent me their design, and it was 1.2 gigs. It was gigantic, and it shouldn't have been that big. It was complex, but it shouldn't have been that big. And it's because they purchase a generator from a different vendor, and they get every nut and bolt, every internal component with it, and they haven't really changed it so that it's lighter and just meets their usage needs. They just need to know a part number and an envelope, right? How much space does it take up? Maybe how much it weighs, right? So that's the next part of this. How do I get the data, bring it in, and then make sure it's, we create it, or, we process it in such a way that it's usable, not just now, but in the future. If you use these things all over the place all the time, and you're going to do that for the next, 3 years as this generator's available or there's motors available, what do I need to do to make it better? Okay. So with that said, let's see what that process looks like. I'm going to go ahead and kick off the process here. It is import, right? That's the easy button, just get it in. But then you're going to want to simplify it. It's going to take a little bit of work. There's tools purpose built for that. And then when you're done, I'm going to show you something that'll help you simplify it even more and achieve, just a much more lighter weight version of the part. You can see an example of this motor. In the example that I'm going to show you, and we're going to be flying through this, we got a 95% file reduction, right? We took out internal little details. We went from 42 megabytes to 214 kilobytes in the end, right? To see a major improvement in performance. And that's just not in this current design, but in the future, if anybody uses it from our library, they'll see the same thing. So don't shoot yourself in the foot. Make sure you process these files so that they're lightweight and usable in the future. So let's go ahead and begin here. And again, we're taking a look at this same model, and we're going to flip it over and take a look at what's underneath it, right? And you'll see right away there is a motor that gets used all over the place. There's 3 or 4 of the same motor. And if we take a look at it and focus in on some of the details here, you'll see there's a lot of details. There's internal stuff that you can't even see that we don't need. So keep that in mind as you do this. If we focus in on the size, initially, right, if we go through the process of importing this over again from the vendor, you'll see this thing is like 20-something megs, right, in size. We don't know if it's going to explode into an assembly or if it's a single part. For us, it's one single part in our system. We want to treat it as such. We don't need the complexity of an assembly. So you'll see some things there, right? The goal is to get this as one purchase part, make it as lightweight as possible, and still know how we connect to it, where shafts go in, where wiring goes in, and how much space it takes up. That's what we need it for. So as we bring it in and open it up, it goes through a conversion process. You have the choice of linking it or converting it. We want to convert it so that we can have some choices. And you could get a preview. And in the preview, as you go through this preview process, you could decide and just see, well, what things are a part of this file. It looks like it's an assembly, and I see motor casings there. I see some internal components and things that we already know we don't want. That internal thing that you see there, I don't know what that is. It says winding, but we're never going to see it. So you could turn it off here. I'm going to leave it in so that I can show you more ways as we import it into our environment that we can simplify it. So we brought it in. It's now an Inventor assembly with parts and components. It brought every single component in, and we just saved it. So let's take a look and see how big it is now, right? And there's a little trick for an assembly. If you want to see truly what the size is, you run a pack and go on it. And you can see it's 40-something megs. It blew up from 20-something megs to 40-something. Already it's getting bigger than we want it. That is too big for a little tiny component of our assembly. So with that said, let's continue and see what we can do to simplify this. We're going to use a series of tools, and within the assembly environment, you could start editing what you really want to maintain in this assembly. And so that internal component, when I launch it, I could pick that edit view tool to say, do I want to include it? Do I want to exclude it? I could change my view to see what's excluded, and that's what we're going to take out. And simply by clicking OK to that, right? On the left-hand side, you can see the winding is now turned off. So, step 1 in simplification, get rid of stuff you don't need. The next step is defining envelopes. So we're creating a representation of the casing there, that gray casing, and you have 2 choices, a box. I don't want to represent it with a box. What's closer is a cylinder. So the option to convert that to a cylinder at some point, right, it's available. So you're going to see here, okay, that's better. You have tools to size that and snap it to the original casing so that it's the exact same diameter. And you could size it accordingly. So great, now I have a cylinder, and I could either get rid of the casing now or maintain it. I'm going to choose to keep it around. The cylinder is not a perfect representation. It's close, but it's not perfect. So I'm going to keep the casing around so that we could refine it later. And you can see the casing underneath there. It's got flat sides, and we're going to refine that just a little bit later. For now, we're going to continue defining an envelope representation of the components. And if you don't see those tools, you can go to the panel and bring out those simplification tools at any time. So it might not be there by default. And if I click on there, right, we're going to go ahead and start maybe defining the envelope for that black plug, right? It's going to be a series of rectangles or boxes um, to represent the different sizes of boxes that I see. And we don't need a lot of detail for that particular plug, but we're going to need some more detail for the white one, the male plug. So this is going to be very, very simplified. But again, it's going to capture the things that we want. So similar process. And in the end, when you're done creating 2 or 3 boxes on top of each other, you can replace that black plug with that uh, boxed version of it there. It's much more lightweight and it doesn't have a lot of detail. So at this point, I think we're ready to maybe continue with the process and create one single simplified part, right? There's other parts that have maybe too much detail. We're going to wait and maybe simplify this differently. Instead of these real simple boxes or rectangles, we're going to refine these a little bit differently once we get into part mode, right? And so creating a simplified part basically takes all this and creates a separate part representation, and you have a choice of ways you can create that. We're going to create multiple bodies, use a metric template in accordance with that, give it a name, and what we have now is one single part, okay, with multiple bodies. So the bodies now show up, and it brought in everything except for the winding. It also brought in extrusions for those boxes that we created that are going to represent, plugs, etc. And so we're going to isolate the casing now, okay, as a body, and we don't want to see the other stuff. And I do want to bring in maybe the box that represents, or the cylinder that represents, that's going to represent the casing. And you can see there's an overlap there. And what we're going to do is we're just going to sketch on top of the solid and use just regular CAD modeling tools to cut away the information. And we can project the geometry from the casing so that we know where that cut is exactly, and continue to use just common sketching tools. So now we're really combining the 3D model with some modeling. But again, it should be less work in terms of measuring that, so that again, we can use common extrusions and cuts to get to what we want. Okay. So, we're going to simplify this and create another solid. And once we have a good representation, we can go back and edit our import of this data, right? And edit the derived assembly. We could turn off the motor casing. It's no longer a part or component of this. It's linked back to the original assembly, but this is now our casing, and ours is better than what we had a minute ago. Okay. So we'll move on to the next part. It'll be a series of, similar processes. I just, for the most part, I want to show you just more tools that are available in part mode. So in a moment, we'll go ahead and isolate the male plug. And we want to maintain a lot of the detail here. So when you're in a part environment, if you don't see the simplification tools, again, you could go to the panel and bring these out. And there's tools there just to remove, edges, rounded off edges, and make this more squared off and simplify this. In addition, there's also tools to start eliminating voids. So there is a void inside of this with all kinds of detail. We don't need it. We're going to plug this up and sort of fill it up, if you will, as if there's nothing inside, just by plugging up the holes. And when you do that, man, we've got the most basic representation of this, and we still know where the wires go, right, on this. And so if we start to bring things back, the only thing that's left are these red components, and we'll streamline the process for this, but that's the only thing left that we need to simplify. The two components are exactly the same, just mirror images. So we're going to focus in on one and really go through the same process of using simplification tools, sketching tools, and just common modeling tools, right? And we are borrowing from the original, so we're borrowing edges, disassociating them eventually, because that red part will go away, and we'll replace it with our own extruded version of the same thing. Okay, so again, you can see us going through that extrusion process, and in the end, what you're going to see is, radiused edges going away, and us getting or ending up with a simplified representation of this. Okay, so when we get to this, right, to this point, we're going to go ahead and save it, and I think you'll see that when you look at the file size, it went down to 630 or something like that. But as one last extra step, right, a little trick, you save it as a SAT file. Okay. You import it back in, and when you import it, it's going to come even smaller. All the information on the left-hand side in the original model is going to be taken away. And as you bring this in, right, you'll have the same visual representation of this, the same boundary conditions, et cetera. But when we look at this newly imported version of this file, it's only 214 kilobytes. So much smaller. And then when you compare it to the original, right, there's not much difference in terms of the space or volume it takes up. Okay, so there's a lot of little tools that we quickly exposed you to. Again, if you want to see where these tools are or focus in just on that process itself of just simplifying, there's lots of information out there. You can certainly talk to us, and we're sharing some of the links as well. Let's